I think this is one of the more interesting things that we can kind of do, like these word problems, a little bit the more interesting things that we can do with quadratics, right? And the foundation is formed out of our understanding of what the vertex is and how do we like interpret it, okay? So this question's asking me, and again, the hard part's coming up with the word problems, right? Mr. Mackay is trying to build a pen for his dogs in his backyard, right? So I went to Home Depot, I bought 600 feet of wood, right? And then I want to know what the dimensions of the pen would be so that I could maximize the area for my dogs to run around in, right? So I don't want to give them a pen that looks like this. Sorry, that's it. I don't want to give them a pen that looks like this, right? Where this is like 598. Sorry, not 598. It'd be half of 300, so 299, 298, 298, 1 and 1. Right? I don't want to give them that because that's not maximizing the area. Right? They just have this long chute to run up and down. It's like so if I multiplied area is length times width, I'm going to get 298 times 1. Well, that's 298. It's not very big. Right? But what if I were to make this, what if I made it 296 by 2? Well, now all of a sudden already, if I took 296 and multiplied by 2, that's already that's like twice as big as before, right? So you can see there's a trend there, right? The problem is I'm not going to sit here and do this till I'm not going to sit here and create a table of values and get to an, like, there's a more efficient way to do this, right? So let's ignore the fact that I showed you this, right? Because this is just me spelling out the question. What I want to know is, let's come up with an algebraic expression. Let's do this with algebra instead of just plugging in numbers until we get to an answer, right? So here's the pen, right? My dogs to run around in, and it's no particular shape. I don't know what shape it's supposed to be yet, right? I know that the area of this pen is going to be length times width, right? Now the other thing I know is that I had enough money to buy 600 feet of material, right? So that means that all the way around here better add up to 600, right? So it's a perimeter, right? So perimeter is equal to, for any rectangle, I get 2 lengths plus 2 widths, right? But how much perimeter do I have? 600. So then I can actually just say, okay, well, 600 is equal to 2L plus 2W. Right? So stepping yourself through this is the hard part of these questions. It's arriving at like the expression that I'm going to work with, right? So now I could do a little bit of algebra on this thing, right? I could say 600 is equal to 2. I'm going to factor the 2 out. L plus W, right? And then I can divide both sides by 2, right? Those would drop out, and then I get 300 is equal to L plus W. And then I'm interested in, like, ultimately the question's like, what are the dimensions going to be? So I'm just going to, like, solve for one of the dimensions there, right? I'm just going to get an algebraic expression for one of the dimensions. So we could say, okay, well, let's solve for the length. So L is going to be equal to, I'm going to take, I'll do this the other way so nobody gets confused. So 300 minus W is going to equal to L, right? Okay. Is everybody okay? This is the hard part of the question. There's one more little thing to do. Okay. And that is to take I have another equation on my page, don't I? I know what the area is. Right? And I just solved for, L. So why can't I just make a substitution for L right there? So let's do that. Well, area is going to be equal to length times width, and then I'm going to replace the L with the L that I just solved for, algebraically. So it's going to be 300 minus W multiplied against W. No more lengths. They're gone. Got rid of them. I only have widths now, right? So I've navigated a way that I've gotten algebraically, I've eliminated the length, right? So now if I were to do some math manipulation or algebra on this thing, I'm going to be able to find what the actual width is, right? So why don't we, for a second, just because this is you're following along and then you're going to follow this process after, I want to distribute this in to there, right? So I'm going to get something that looks like this, 300W minus W squared. Right? Now I'm at something that kind of looks a little bit familiar. And if I were to rewrite it, I could rewrite it if I wanted to, right? I could go negative W squared plus 300W. Okay? We are now at the stage that we were at for number 13, right? Or 12, whatever, 12A. Where it gave us the equation, right? Because now I'm interested in what's the question asking me for? And what did I tell you guys to do whenever I saw that one particular word? If I see this word, let's complete the square. If I ever see the word maximize or minimum, complete the square. Right? So you can see how completing the square is just a process to allow us to answer questions, right? So if I switch this thing, this is pretty much in standard form, isn't it? Plus C, right? So if I switch this, the goal of completing the square is to switch something into vertex form so that I could read the vertex. The vertex being the maximum or minimum value of whatever quadratic function we're talking about, right? In this case, when I put that on top, it's going to give me a width of the pen that maximizes the area when I get it there, right? Does that make sense? So I'm just going to work through the completing the square to switch it to vertex form. Once I get it in vertex form, I can read the vertex, which ultimately answers the maximum area, right? Everybody okay? This is the hard part. This is not, I don't expect you to get this right away, but the completing the square, I'd like to see you be able to do the completing the square part. We can work on the word problems. That's the end goal. This whole unit is to get you to answer these word problems, right? Okay, so this is basically standard form, and now I'm just going to complete the square on this, right? Now the problem is it's not 1 out front, right? It's -1, so I'm just going to factor that out, right? And it's going to be W squared minus 300W. Okay. And then remember, this is like step 1, and step 2 now is let's find the Z value, right? The Z value is the B value divided by 2 squared, which is -300 divided by 2 squared, which is -150. This is B. Is that the one you're talking about?
Yeah.
It's just the B value. So if remember standard form's written in ax squared plus bx plus c. So B, that's just B. That's just me being a little bit sloppy. The B value. So in this question, it's the 300 because it's right before the W, right? The Does that make sense?
Yeah.
Sorry. Okay. Okay. And then you can see the B value came from here, right? The B is the negative 300, which comes from right here. And then once I divide it by 2, it's 150, negative 150. And then I just have to square 150. So 150 times 150. It's 22,500. Right. So that's my Z value, right? And then if you've done enough completing the square questions, it should be identify the fact that this is kind of like the magic number there, right? But I'll do the rest of the steps here. So we'll do negative 1. Inside the square brackets, we're going to go W squared minus 300W plus 22,500 minus 22,500. Okay? And then the first 3 terms condense down to this magic number, right? I get right. Remember, I didn't want to bother you with the nitty-gritties of that process. It just is what it is, and it comes out that way. And then minus 22,500, the square bracket. And then I just distribute the negative 1 in. And then the question's over. I read the vertex. Right. So I get a negative out front, which makes sense because it's asking me for a maximum, so I must know that the parabola is opening down, right? W minus 150 squared plus 22,500. So my vertex, the vertex is 150 and 22,500, right? Okay. Now, I see a W. What did we say W was in our question? The width of the pen, right? And then, so if that's the width, then what's this piece here? The area. So basically I have this graph, right? I have this graph where I'm plotting width versus area. Right? And then if I were to do this, like from the beginning, I could just go like this, blah, blah, like I do all the different dimensions. I would reach this answer, right? At a maximum. And then anything past that, it would start decreasing again. Right? Well, this is 22,500. Right? And it occurs when the width is 150. Okay? So that's what the vertex means in this question. So we could say we get a max area of 22,500 when the width is 150. Okay. Now, just to spark your curiosity, what sort of shape do we get if the width was 150? Do we know? Yeah, so I ultimately want to know, like, again, if we went back up to my picture there, right? And I drew the picture. Okay. Right, and I'm going to draw the picture, right? Let's say this is the width. The width is 150, right? But this is also a width. So, and this is the length. And if I added, remember our perimeter was equal to, it had to add the 600, right? Well, 150 and 150 is 300. That's exactly halfway, right? So then these ones must be 150, right? That's me solving it conceptually, right? Just by looking at a picture, right? But I could, and this will give me the same answer, I could take this, right? I know what the length is supposed to be, right? I said that the length was supposed to be equal to 300 minus W. That was one of the equations I isolated for, right? So if I take the width that I solved for, the 150, and I plug it in where the W is, it's going to tell me what the length is, right? So length is equal to 300 minus 150, which is 150. Right? And then you can deduce that, like, just by doing one of these questions, right, that the object or like the shape that maximizes the area is a square, right? Does that make sense? So when all the sides are the same length, right, that maximizes the area. Because 150 times 150, if I were to start checking the tables of values, 150 times 150 had better equal the 22,500, right? Right? But if I manipulate these in any way, right? So if I make this 149 multiplied by 151, it better be less than that number, right? It's 22,499. Yes?
Can you not just divide by 4? Because, like, isn't the square always, like, the maximum?
Yeah. Yeah. Yes.
But on a test, you'd rather...
On a test, then, like, I might not ask you this question on a test, but it's a starting point for us, right? It's a very accessible starting point, right? Because it's like, how do I write, like, we're dealing with two equations that we're very familiar with, or should be, right? Perimeter and area of a rectangle. So it's a very accessible starting point that we can, like, manipulate equations and go through this process to answer the question that we can conceptually just deduce right from the beginning, right? Now, what we will do today, there are questions that are a little bit more tricky, but they follow this exact same process, right? You come up with the equations, you get it, you expand, right? You get it in standard form, yeah. And then complete the square to maximize the area and tell me the information like you're reading it off, right? So one of the other questions we'll do today, maybe, is what happens if, like, I use my, like, let's say I'm just doing the backyard instead of a pen, and I use my house as one of the side lengths. Not a square anymore, right? That's how we can throw wrenches and things. But this is because you're going to follow the exact same process. It's basically the exact same question with one little manipulate, right? So why don't you guys take the rest of the class, okay? And we'll work on page, I think it's on 134 now. Work on 16 and 17, okay? They're questions that you have to come up with the equations now, okay? And if they're too hard, we'll look at them together, okay? We'll maybe start the lesson depending on what they are, okay?